Thanks everybody. Good that we have everybody joining online today. And during the summer, right? I mean, like today it's hot, but there are going to be a few more days during summer which will be even hotter than this. So that is when we'll either do the classes online for those days, or I will ask all of you. I mean, whoever is coming in person to go inside the house. I mean, we'll not do that in the classroom because it's going to be super hot and I don't want to have anybody in my class fall sick. Okay, so that is one. Quick announcement. Next weekend I'm going to be in California. So that means it'll be online for everybody, only for next weekend. Okay, because I'm not here in person. For Vaibhav, Rotvik, and see what's up. It's not going to be any different. They are anyways always online. But for Isha, Tharv, and Praneeth, we'll be doing it online next weekend. Okay. All right. So let's get started. So do you guys remember what we're going to do today? I had sent a message in the WhatsApp group. Not sure if you guys got a chance to look at it. So I mentioned this. So we're going to talk about operations with rational expressions, and if we have enough time, then we'll talk about nonlinear functions, evaluating functions, finding values, and composite functions. So these are the things that we're going to cover. So this is still part of Unit 12 of SAT, Digital SAT Prep course. So let's start with rational expressions. Do you guys know what is rational expression? Any guess? Anything that you can relate, anything that you recall? Nothing, I'm not trying to put anybody on the spot. I'm just trying to see if you guys have come across this. Rational expression. No? That's okay. That's okay. That's perfectly fine.
Numbers that are perfect squares.
I'm sorry?
The numbers that come from the perfect square.
Rational expressions. Rational numbers, I'll probably try relating it with that. So let's first understand what do we mean by expression, right? I mean, we all know that anything that is written as monomial or polynomial, right? Like 5x squared or 6y squared minus 8y plus 20, or something like 8x to the power 4 minus 14x squared plus 16x minus 12. These are expressions, right? This is monomial, these are polynomials. Here we are talking about, these are all expressions. Now we are talking about rational expressions. So, do you guys remember what is called a rational number? A rational number. So, if first of all, we know what is a natural number, whole number, integers, that we all know, correct? Yeah. We know what is a fraction. We know what is a decimal also. Yeah. Then so basically, if you look at rational numbers, rational number is a set of all the numbers that can be in the form of fraction, decimals, square root, or anything that can be put on a number line. Anything that can be put on a number line. So that's why I'm saying rational number is a superset or a set of numbers that includes every number in any form, be it in the integer form, be it in a fraction form, be it in a decimal form, any form that can be plotted on a number line. So if you look at number 9, I will say 0, 1, 2, minus 1, minus 2, and in between you have 0.1, 0.2, 0.3, 0.4, and then also if you have to plot something like a square root, that also goes in here. You can plot that in the number line. Okay, there are different ways to do it. We'll learn that in the coming classes as well. So what I'm trying to say is, any and every number that can be plotted on a number line, be it a integer, be it a whole number, be it a natural number, be it a fraction, be it a decimal, or any square root number, that is called rational number. Anything which is rational, anything which is technically possible. And for the sake of simplicity, when you look at the whole numbers, meaning without any fraction, without any decimal, those are called integers. Similarly, when you look at rational numbers, the obvious interpretation is, okay, it is something in the form of a fraction. Though it includes natural numbers also, but then mostly anything that can be represented in the form of a fraction. That's how you can relate it. So that's why when we talk, before I move first, when you say rational number, your simple interpretation would be anything that can be represented in a form of a fraction. Now, if I say 0.2 or 1 or 5 by 3, what is the difference? This is a fraction, this is a decimal, this is a natural number. Yeah? I can represent this in the form of a fraction. I can represent this in the form of a fraction. This is all in the form of a fraction. So anything and everything that can be represented in the form of a fraction or gives you a view of a fraction is called rational number. Is that okay? Yeah? Okay. Now it's the time to relate. When I said rational expression, meaning an expression which can be written in the form of a fraction. Now you look at this. What is this? This is a rational expression where your numerator and denominator, or a numerator or only the denominator, is in the form of a expression. Okay, but this is in the form of fraction. So this is a fraction where one of the numerator or denominator or both of them are in the form of a expression which has constants and variables both. Meaning, if you see something written in the fraction form where you have expressions written either way or both ways, that is what is qualified to be called a rational expression. An expression which is in the form of a fraction. Is that okay? Anybody have any doubt? Rutvik, Isha, Atharv?
What's like considered to be like the opposite of a rational number? Like irrational, something like that?
There is something called irrational number as well. And we can talk about that as well. So, rational number is any number which is technically possible, anything that you can plot on a number line, or anything that you can derive which has a finite value. Okay? Irrational number is when you start talking about things which are a little complicated. Okay? Where you have, yeah, Rutvik, you're saying something?
Nothing.
Okay. No, so I'm saying we'll go deeper into that irrational number, but for the sake of simplicity, since we're talking about rational expressions, I'm saying the easiest way to relate, we know what is an expression. When we say rational expression, it is as simple as to be understood as when the expression is written in the form of a fraction, meaning I have something in the numerator, something in the denominator, where I have either numerator or denominator or both of them written in the form of expression. So if I say this, 1 by x squared minus 7 this is also a rational expression because in the denominator I have the expression. If I say 5x squared plus 2x minus 7 by 8, this is also a rational expression.
Okay, sir.
Okay, so rational and irrational numbers, when we talk about it, obviously, we'll go deeper into it. But right now, I'm just trying to give you a view that, okay, we talked about expressions yesterday, we talked about polynomials, monomials, and today we're talking about rational expressions. So I'm just telling you guys how do we relate, what is the difference between expression and a rational expression. Okay? Now, we will do more things about it. Let's spend some time and then I'll give you guys an opportunity to do some practice and then we'll see where do we go. So ultimately we are going to talk about, first thing is understanding what is a rational expression, and then we'll look at the different operations that we can do with the rational expressions, be it addition, subtraction, multiplication and possible division. Okay. Now let's say if I have 5x squared plus 25x minus 25 divided by let me make it okay. Let me give you guys a legitimate sum so that we can solve it. Okay, this is a rational expression. Okay, I want to solve this one. Okay, or somebody says divide this by this. Can you guys tell me how we can solve this? I have this rational expression and I have this rational expression. Somebody says divide this by this. Okay, not trying to complicate this, but let's look at the approach first and then we'll try solving it. Okay. If you have any expression, anything like this, our objective always has to be to simplify things. Whatever we have, written as a cryptic formula or a complex formula, we should look at making it smaller, simpler, easier to deal with. That should be our first goal. Because math, any math that you come across, ultimately you have to solve it by making it simplified, by making it simpler. If somebody says divide 1250 by 125, this looks difficult, but no, you say fine, okay, this is 125 into 10, so 125 into 10, and you break it down. Say, okay, fine, it's only 10. So this looks complicated, but actually the answer is simple. What I'm saying is, here also when you have any question to solve like this, your approach has to be, first let me try simplifying it. My first attempt here would be, again, the same theory that I have bored you guys with, right? TRAN. Trust is there always. Read, analyze, and then do it. Read this. 5x squared plus 75x plus 250 by this, then this. Now, I can do division multiplication, but right now I don't see this is x plus 5, this is x plus 10. I cannot divide these two. First thing is, let's see, this guy is the most complicated part. So this is when I'm reading it, I'm analyzing also. So if I can simplify this part, then we'll be able to figure out if there's something that we can do about it. Yeah? So, fine. What all we can do to simplify things? Now look at this. 5x squared plus 75x plus 250. What is common in all the terms here? 5. Let me take 5 out first. Then becomes x squared plus 15x plus 50. Yeah? By x plus 5 divided by x plus 10. Yeah? So far I'm not done anything. I'm only trying to see wherever I have an opportunity to simplify things, that's what I'm doing. Okay? Now you guys have to remember what we, or recall what we did yesterday. I'm taking this, okay, let it be like this. I'm going from here to here. Now I'm going to use this part of the board. Now look at this. This is a square plus a into something into b, and I kind of messed it up. Okay, no, that's fine. That's fine, it's okay. A square plus some a and something, and then this. But this is not looking like something multiplied by 2. This is not like, it's not in the form of a plus b whole square, okay? Because a plus b whole square gives me a square plus 2ab plus b square. So look at this guy. This is not something which is a multiple of 2. This is 15. This is an odd number. So this one doesn't look like the case. Same time, 50 is not a square of a number. 7 7 are 49. So a plus b whole square strategy will not work here. This is not in the form of this. So let's knock it off. Now the second option that we have is, can I break this into a plus b form? a plus b form. Meaning break this into 2 parts and then multiplying that will give me this. Now let's look at 15. 15 I can write in how many ways? How I can break it? 1 plus 14, 2 plus 13, 3 plus 12, 4 plus 11, 5 plus 10, 6 plus 9, 7 plus 8, and then 9 plus 6, and then same thing repeats. These are the ways I can break 15. Yeah? Again remember, my plan is to make a plus b equal to a into b. Okay? A plus b, meaning break this into 2 parts, and then if I multiply these 2 parts, I should get the third part. That's my strategy. Okay? Now 15, I can break it in this many ways. 1 plus 14, 2 plus 13, 3 plus 12. Which of them? Okay, now 1 and 14. 14 times 1 is what? 14. Not meeting this guy. 2 plus 13. So 2 into 13 is 26. Nowhere close to this. 3 into 12, 36. Nowhere close to this. 4 into 11, 44. Not close to this. 5 into 10, 50. We got a match. Yeah? So what we will do is, we'll keep 5 outside now, or let's make it a bigger bracket. X square plus 15x. X square plus 15x, I will break into 2 parts. 10x plus 5x plus whatever I have is 50. Okay, divided by x plus 5 divided by x plus 10. So see here, I am doing it like writing a story. Yeah, I had the equation. I said okay, fine. I am only touching this part, so I took the common thing out and everything I kept as is. So this is my story. This is the flow of the story. Okay, I'm doing things step by step. When you do it step by step, if you go wrong anywhere, you will be able to figure out where did you go wrong and where you have to fix. Okay, so don't rush, don't jump steps. Do it step by step always. Okay. Now you are here. You got this. So now let me create some space here on the board. Now whatever I have here, what I will do? Okay, now I have 5. Here, let me put them in pairs. So x squared plus 10x is one pair, and 5x plus 50 is my another pair. Okay? I have not done anything. I just grouped them. Okay? Nothing more. Okay? Now x plus 5. Let's put inside the bracket so that it looks cleaner. inside the bracket. Now, look at this guy. 5 is out, so let it remain outside. Here, what is common? X. I'll take x out. So it becomes x plus 10. Plus, here, what is common? 5. I'll take 5 out. This becomes x plus 10. By x plus 5. Yeah? Are you guys with me so far? Am I complicating it?
No.
No. Isha, Athar, am I going in the normal flow or am I making it look very cryptic?
No.
It's fine?
You got it.
Okay. Yeah. Now, whatever I got here, I'm again creating some space on the board. What I will do here is, let's do this, x plus 5. Now, what I see, this and this is common, so I'm just grouping them, right? Consolidating it. So, this I can write as what? X plus 10 is common, so I can say x plus 5 into x plus 10. Yeah? Then divided by x plus 5 and divided by x plus 10. Now you see that this is factorized already. Yeah? So I can as well write this as 5 into x plus 5 into x plus 10 divided by x plus 5 and divided by x plus 10. Okay? Yep. Now x plus 5 and x plus 5, this you can knock off. What you are left with is 5 into x plus 10 divided by x plus 10. What you can do, I don't know if I told you guys or not, if I have to divide, if I have to change division to multiplication, that's the only way I can do it. So this is like x plus 10 by 1, okay? If I have to change this, somebody gets upset and starts dancing. Meaning, this fraction, what happens when I convert the division to multiplication, it dances and flips, it goes upside down. This becomes x by 10. X plus 10, 1 by x plus 10. Now, you have this 5 into this by this. Your answer is 5. So again, repeating the dance thing, right? I was saying that whenever you are doing a division with a fraction, okay? If I have 1 by 5 divided by 2 by 9, okay? The division is nothing but a dance. D stands for dance, D stands for division, okay? Fraction division, okay? Now, 1 by 5, this is division. I'll have to convert to multiplication. I don't want to divide with a fraction, okay? So I'll have to convert that. And whenever I convert, somebody gets upset and dances and flips upside down. So see, as soon as I converted this sign, division to multiplication, this guy got upset and flips or dances, whatever you call it. So whatever was the denominator goes up, whatever was in the numerator, that comes down. And that's a universal thing. So if you have to divide 1 by, let's say, x plus 5 into x minus 9 divided by x plus 4. Meaning, what you can do is you can convert this into a fraction. You can always convert a number into a fraction. And now, to do the division, you will say, okay, fine. Minus 9 by 1. And I will convert this into multiplication. And somebody gets upset and starts dancing or flips, whatever you call it. 1 goes up and whatever you have in the numerator comes down. And then you can do your job. Okay? So, remember, fraction division is nothing but a dance. Somebody flips upside down or starts dancing, whatever you call it. I mean, this is how I keep on teaching the smaller kids so that they don't feel stressed out. But if this is fun, why not for us? Yeah? Alright. So we just looked at a division of a rational expression by another rational expression. That's what we did. Yeah? Now let's look at, let's say, let's say if you have to sum these two, what will you do? It's a rational expression and we have to add the two rational expressions. How will you do it? Can you guys just try doing it? This is one of the easiest sum, but if you want to try it once. There are 2-3 ways to solve it. I have one rational expression, I'm just trying to add this with another one. I'm giving you guys, let's say, 2-3 minutes. So try it. I mean, again, don't stress yourself too much. Just think about it and then start doing it. Okay? There could be 2 or 3 ways to solve it. We will try all the options, but I'm just giving you guys 2 minutes to have some fun with this math. Let's see. Everybody got the sum, right? It's x square plus 5x minus 6 divided by x minus 2 plus 5x square minus 10x by x minus 2. And I'm not really interested in the answer. I would want to know your approach, how you would want to solve it. That's what I'm interested in right now. So if you are ready with the approach, you can just raise your hand and we can talk. Okay. Yes. Yes, Vaibhav.
Sir, I not got the answer, but I tried my best.
That's fine. This is okay. I mean, this is the class where I want you to make mistake. Tell me.
So what I got was like 6x squared minus 5x minus 6 divided by x minus 2.
This is x squared plus 5x minus 6. Okay?
So what I got was like 6x squared
Uh-huh.
minus 5x
Okay? Yeah.
minus 5x minus 6
Uh-huh.
by divided by
X
x minus 2.
Yeah. Okay? That is one answer. It's very simple, right? It's like how you add the fractions, right? You took the LCM, both are the same, so you will say, okay, fine, this is the nearest common. So I get x squared plus 5x minus 6 plus 5x squared minus 10x. Yeah? And then you add the similar things together, right? So x squared and 5x squared you added, it became 6x squared. This 5x plus and minus 10x became minus 5x. Yeah? And then minus 6. And then divided by x minus 2. This is one answer. Yeah? By x minus 2. There could be other answer also. Yeah? Okay. Let's look at that. So this is one way to solve it, right? I mean, everybody got this answer? Or somebody got a different answer also? No? So, that is why, see this, whatever you guys got, that is one way to solve it, okay? But math is, I would not say it is a very creative subject, but it's a very interesting subject for sure. Now look at this. You guys looked at the denominator, oh this is common, let's go ahead. This is 1. Now, because of this what we got was 6x squared minus 5x minus 6 by x plus 2. It is still in the form of a rational expression. Can you simplify it further? Let's see. Now here, if I am doing it, one way is this. Is there something else that I observe here? Look at this piece alone. 5x is something common. Let me see. If I take 5x common out, what I am left with? This is x minus 2 divided by x minus 2. Okay? And then look at this guy. We have learned a little bit of factorization. Here if you look at this is minus 6. What is that? How do I break 5 so that the multiple of that gives me 6? That's a plus b and ab, this approach. This is anyway not a square plus 2ab plus b square, but can I break it using this? This is a plus b. If I break this into 2 pieces, can I get this one? Now, 5 I can say 3x, okay. Yeah. Okay. You will.
2 and, sir,
Yeah?
2 and 3.
2 and 3 is fine, but what happens is 2 and 3 both will be positive here, okay?
Oh.
If I multiply 2 positives, it will never give me negative, okay? So the question is not helping me there, okay? What, I mean, again, that will not be a great answer, so fine. We'll find out. So we'll probably go with the way you guys solved it. If I had an option to factorize this, I would have factorized this and simplified this and added them together. That is what I was saying. So here, if I would have picked up this, if I would have picked up minus 5 plus this, then this would have worked for us. Okay? Then this would have been x squared minus 2x minus 3x plus 6 divided by x minus 2. Okay? And then we would have combined these two. That would have given me x minus 2, and here minus 3 out, x minus 2 by x minus 2. Okay? So this would have become, this part alone would have become x minus 3 into x minus 2 by x minus 2. And then these two would have got knocked off and that would have been our answer. But since this is not fitting in here with this approach, so then we'll have to go with what you guys did. Okay? So what I'm saying is, there could be multiple ways to solve a sum. Okay? Explore all of them, and it might so happen, see, if you know one approach and then you go with that approach in the exam, and then somehow that slips out of your mind during the exam, you fail to recall, you'll be stuck. If you explore, keep on exploring different options. Same thing you will do in the exam, and you will have multiple options to choose from, and then the chances of you getting the right answer is better. Being able to solve it faster is also more. Yeah? Any questions so far? Rutvik, Isha, Atarf. Since I don't see you guys, I don't know. I cannot gauge your confidence level or comfort level either.
No, I got it.
You got it?
No,
Yeah, you're fine? Okay. And my request always would be, since during the summer we'll end up doing a few more classes online, so I would request you guys to stay on video as long as that is not a problem, because that way it helps me interact better with you guys. Okay? So Alright, so we looked at what is a rational expression. There is nothing fancy or funky about it, okay? We know factorization, so we will use factorization techniques for dealing with addition, subtraction, multiplication or division of rational expressions. I will not probably try doing more sums here because there is nothing new you guys will be able to do. I will let you guys practice in the unit test as part of a unit test, and then if you find some questions or some problems that we are not able to solve, that is when it gives me an opportunity to teach that additionally. Okay. So otherwise, all that we do as part of rational expressions operations, it's all related to how do we do factorization. So as long as you do know factorization well, you'll be able to solve those sums. Okay. Making sense? Shall we move on to the next topic? Yeah?
Yes, sir.
Okay. A third Visha?
Yeah.
Yeah, okay. So what was the next topic then? Our next topic was non-linear functions. Evaluating functions and composite functions. What is a function? First, let's try recollecting what is a function. Then we'll talk about what is a non-linear function and composite functions. Tell me what is a function again. Give me something like a relatable example. Okay, something that you can match in a real time scenario. Something that a layman can understand. What is a function? We have talked about equation and expressions recently, right?
A function that has input and output.
Exactly.
Input and output.
Yes.
Like X and Y.
Yes.
Wait, isn't function a part of an operation?
Function also helps you do operations, but like what Vaibhav said, function is an opportunity or is a situation or a mathematical setup where you give an input and it gives you an output. Okay. Now let's look at the little practical side of it. When you say, remember you would have heard people say, how much marks anybody can get in an exam is a function of how much you prepare. Yeah? Yeah? This is your score is a function of how hardworking you are. Yeah? So when you say is a function of, so your score is a function of your hard work. Your bank balance is a function of your investments. Yeah? So that is how you can relate. Something is a function of something. Meaning if you do one thing, you will have a corresponding value for the other thing. Let's say if I start working out, okay? And I start doing push-ups, sit-ups, start going to gym, start spending 1 hour every day. What will be the outcome? I'll have better muscles. I'll probably look more fit, maybe younger also. Possibility. Yeah? So my health, my appearance or the size of my biceps is a function of how much time I spend in gym. How much workout I do. Yeah? So same way, when you say function, something is a function of x or y is a function of x. Meaning if the value of x changes, value of y changes. Or value of x determines what will be the value of y. Okay? If I write a function like this, saying y is a function of x, what it means is, in simple English, okay? This is how we read. Y is equal to function of x. Meaning, value of y is determined by x. By the value of x. Okay? Are you guys with me so far?
Yeah.
Yeah? Oh, okay. So now, but just saying this doesn't give any clue. It makes it more meaningful. Y, which is a function of x, is equals to x square plus x cube plus 2. Now, you can read this as y is a function of x, and also you can read this as y equal to x cube plus 2. Meaning now, here the value of x will determine what will be the value of y. If now let's look at this. If x equals to 1, what is the value of y? Based on this function?
1.
If x equals to 1, what is the value of y? We will just substitute the value of x here. So x equals to 1. So it will be 1 cube plus 2. So it will be 3. When x is 2, what is my value of y? 2 cube plus 2, that is 8 plus 2 equals to 10. When x equals 3, what is the value of y? 3 cube plus 2, that is 3 cube plus 2, which is 27 plus 2, 29. Yeah? So here, whatever I am doing here, this is not so important. What is important is understanding this part of it. Whenever you have one input which gives you a corresponding output. Here what is my input? X is my input. What is my output? Y is my output. For every input of X, I have a corresponding value of Y. Yeah? This is my function. This is my classic example of a function. And there is no limitation. I can have a function like this. Now I am not writing y equal to a function of x, okay? I am just being lazy. I am saying this y equals to 3x plus 7. I have another function where y is 2x square plus 5x plus 9, and third one is y equals, let's see, okay. These are three functions or equations, okay. This is written in the form of an equation, okay, but our interpretation is this is also a function where y is a function of x. Value of y depends on the value of x, okay. And this is the reason why you will see that people use functions, equations and expressions interchangeably, okay. The only outlier here is the expression which doesn't have an equal to sign. But you will see functions and equations are used interchangeably. And that is why I keep on stressing on this thing, okay. That whenever I have something written like this, I will say, okay, fine. That means function of x. My y is a function of x, which is equal to 3x plus 7. Okay. If you guys want to keep it simple for you, you will say, okay, fine. Let's put a little bit of effort and say y equal to function of x, which is equal to 2x square plus 5x plus 9. So this can be read in two steps. You will say my y is a function of x, and this is the how part of it. When you have the equation written, that gives you the how part of it. How it is related. What is the relationship? When something changes here, what will be corresponding value for this? Okay? So this is the logical representation and this is the actual representation. Okay? So that's why you can write y equal to this. This is also a function. This is the actual function actually. But if you say y equal to function of x, only look at this part. This is just a logical representation which says, okay, fine. if you want to know the value of y, you have to know the value of x first, and that will determine what will be the value of y. Okay? Are you guys with me so far? Confusing? Yeah? No? Isha? Rutvik? Everybody okay?
Yes.
Atharv?
Yes, sir.
Okay. No, and again, as I say, I'm not a perfect teacher. I can commit mistakes. So that's why don't trust me. Keep checking whatever I tell. We will check and we'll make sure that you guys learn it the right way. Because if I learn something not the right way, I'm still okay. But you guys learning something wrong is going to hurt. So let's not do that. Okay. Yeah, Vaibhav, you're saying something.
So sir, like if an input has like two outputs, like what is it called?
An input has two output. That's a good question. And honestly speaking, I have not thought about it. But let's see. When we do more sums, we'll be able to relate. Now you give me a real-time scenario when that will happen. Are you saying that you will have value of x as 1, x equal to 1 will give you two values of y, 2 and 3? Are you saying so? Could be? Is that what you're saying? No, I'm thinking, I'm struggling with myself right now, okay? I'm also trying to think, based on the situation that you've given me, I'm trying to recollect, will I ever have a situation where for one input I will have two outputs? Let this be an interesting exercise for everybody, okay? And it need not be a mathematical answer, okay? It can be anything practically relatable also, okay? Keep that in mind. If anybody comes across a situation where you give one input and gives you two outputs for that, we will talk, okay? Mostly, with respect to whatever we learned as part of SAT, based on my study, okay, I have done the entire Khan Academy myself, okay, before I start teaching you guys. So I have not seen a situation like this. I don't recall one, but if we come across that, we'll discuss and debate, okay? We'll figure out, yeah? But for now, we'll go with the assumption that for every input, there'll be possibly one output only. Now, let's look at this. We have one function like this, y equal to 3x plus 7. Second one is 2x squared plus 5x plus 9. And third is 3x cubed plus 2x minus 12. And these are random functions, okay? I have not put any thought around this. I've just written them. Let's look at x equal to 2. Let's put x equal to 2 in all the three equations, see what is the corresponding value of y, okay? Let's see, if we will ever get two output for one input. My value of x equals to 2. In this case, if x equals to 2, what is the value of y? Y equals 3 into 2 plus 7. So 3 into 2 is 6 plus 7, which is 13. Okay. So far, one answer. Okay. Let's look at this one, quadratic equation. Now, here also I put x equals to 2. What is my value of y? That is 2 into x squared. 2 into 2 squared. That is 2 into 2, 4 into 2, 8. 8 plus 2 into 5, 10 plus 9. I got 18 plus 9, 27. Okay. Now, if I put the same value x equals to 2 in this equation also, it becomes 3 into 2 cube. That is 8. So 8 is 24. 24 plus 2 into 2, 4 plus minus 12. It gives me 24 plus 4, 28 minus 12 is 16. So far it has given us only one answer. So that's what I'm saying. For now, I'm going with the assumption that we will have, for every input there will be one corresponding output. That is what mostly a function does. But I will still wait for an opportunity where we come across a situation where for one input we get more than one output. Okay? And I will wait to hear back from you guys to see if we have any such situation. Okay? Yeah? Now, so with respect to functions, right? It's simple. It's one input gives you one output. Every value of one variable gives you corresponding value of the other variable. So that is what we have seen. So mostly what you will see is, okay, y equals to 6x squared minus 7x plus 2. Find out for x equals to 7 what is the value of y. This kind of question I have seen a lot, and that's what you will end up dealing with also. So we'll do, when you do practice, you will find this out. Now I said non-linear functions. What do I mean by that? Non-linear function, that's what I started with, right? If you remember, if you see the topic that I mentioned for today, that says non-linear functions, evaluating function and composite functions. So what we have done right now is we have done evaluation of functions. For every value of x, what is the value of y? This is the evaluation part of it, okay? Finding different value of one variable based on other one, that is evaluation part of it. Now we have talked about what is a non-linear function and what is a composite function. That's what we have to do, okay? So, what do we mean by non-linear function?
Sir, if I'm not wrong, I think it is like the input that has two outputs.
Okay, so this is, how many of you know, yep, somebody has raised hand.
A
Yes.
non-linear function would be like if you plot the y points, the y that you get as coordinates, it wouldn't plot a straight line but a curved line.
Right. So here, that is the understanding that we want to build here. Now, when you said Vaibhav, that non-linear function is where for one value of x you might have corresponding two values of y. You might be correct, okay, but I was just not wanting to jump the gun, so that's why I stopped you, okay. So let's put our understanding around that one quickly, okay. Now, what is a linear function? What is a linear function first? Tell me.
Something like that's equal, like the input equals to the output.
Linear function. Okay, now let's break it down. If you look at the spelling of this, line and then you have an AR. AR is augmented reality. Yeah, we are not talking about AR, VR in this class, okay? But if you look at this, linear has two parts, and one part is actually a line. Meaning a function which helps you draw a straight line is called a linear function. Now, you try relating that with y equals to mx plus c. The line intersect form that you would have learned or heard about in the past. If not, that's also fine. But this is called a line intercept form for a straight line. Other one is called standard form, which is called ax plus by plus c equals 0. These are the two equations that we use for drawing straight line. First one is called line intercept form, second one is called standard form. Okay? So these are the equations which is used for drawing straight line in a coordinate plane. We'll probably we'll come to this one also when we finish this unit. When we come to the coordinate planes and all, that is when we'll talk about it. Hey Shan, you have joined 5 minutes early, so you'll have to silently listen what the senior kids are learning, okay? Or you can join after 5 minutes. That's either way is fine. Okay?
Okay.
Now, all the equations or the functions that help us draw a straight line in a coordinate plane, that is called a linear function. Okay? A linear equation. Now, when I say non-linear, that is when it is just the reverse of what I said. Any equation or a function, if it helps you draw a not a straight line, that is what is called a non-linear function. Now look at this. Ax square plus by square plus c equals to 0. This one, and look at this, y equal to mx plus c. Here the value of c and this is not, nothing is matching, okay? These are just two forms. Look at this equation, look at this equation. In this equation, all the variables, the maximum power on that is 1. Okay? Here, you see the variables have power exponent as more than 1. So the simple thing is, any equation that has all power 1 or below 1, that helps you form a straight line. Okay? That is why it's called a linear equation. Every equation or expression which has power more than 1, that never will allow you to draw a straight line. It will be a parabola. Okay? And that's why it is called non-linear function or non-linear equation. Okay? We'll talk about these, how to solve for A and B for this kind of situation, but in this particular unit, you just have to know what is a non-linear function, what is a linear function, what is a non-linear function, and how do we get output for one given input. And then when it comes to solving these equations, that will be in the earlier unit that we'll cover later on. Okay? Yeah? Anybody, any questions? No?
I guess no.
Sorry, beta?
No.
No? Okay.
No.
Okay. Now, I know I'm rushing for it, but one last thing that we want to learn is called composite function. Function of function. What is a composite value when you have two things put together? So when you say composite function, this is like this. Let's say y is function of x and x is function of g. Okay? Let's say, or I'll put it this way. Y is function of x and x is function of g. So that way you can say function, instead of x you will say function of g. Okay? Meaning it's a function of function. That's what is composite function. Composite. Multiple things together. Okay? One thing superimposing something else. Or in simple terms, this is like this. X is child of y. Okay? And g is child of x. Okay? Child and grandparent. Yeah? That's how it is. So I'll leave it there, okay? I'll not probably go deeper into it. Let's try doing all the sums related to these two lessons that we have learned today. And I'll give you guys the link for this one, okay? And all the new kids who have not seen the videos of the class, I would request you guys to watch the video. And if you don't mind, you can probably subscribe also, because every time when I upload a video for you guys, you'll get a notification as well. You don't have to keep looking for it, okay? So I'll send out the link for the class. I have already sent it for yesterday's class, but for today's class I will send it maybe tonight or early morning tomorrow. And then I'll send you guys the assignment link by tomorrow end of day or by latest by Tuesday, okay? And then for in the remaining 3 days you will try doing the sums, and then we'll see what was working, what was not working, and then we'll take it from there. Yeah? All right?